Hey, hi. To run the code in a collab, what you have to do, you just have to go to the collab official notebook, and then you can create a new notebook so that it will give you empty notebook. Okay, so like this you will get it. Okay, so first thing which you have to do, you have to upload this zip file. Okay, I'll be giving you one zip file that you have to upload in the notebook. I'll be giving you this zip file. Okay, so what you have to do, you have to just upload this file. You can click to this storage icon. Okay, and then it will connect with your terminal. So here you can upload by clicking on this button. So with this you will be able to upload the uh, zip file. Okay, and once the system once this upload completed, then what you have to do, then you have to make it unzip. I will give you this command. Okay, but I suggest if you try buy with your own, then that will be very helpful. Okay, so once you do this unzip thing, so it will make it unzip and provide you all the codes. Okay, like this. So then what you have to do, then you have to type one command which is like cd models, cd collab, so that will change the directory to collab, because we have like we have this collab notebook, and inside this we have all the files. So once you're done with this, then what you have to do, then you have to go to the you have to double click this predict .py file, and then you have to copy this complete code, and you have to paste it as it is. Okay, and then you just have to uh, run this block. Okay, and also before running this block, okay, so what you have to do, you have to run one more command which is this one. We have to make a directory with this output folder so that we can store our outputs. So before this code you have to run this command. Okay, cannot create, why cannot create, just a second. Okay, I think we have to create folders one by one. Okay, so yeah, so we have created a folder. So when you refresh this, you will create this folder. Okay, and then you have to uh, run this code. Okay, you can run the code by clicking shift enter. Okay, so you have to press shift enter, then it will run the code. Or else what you can do, you can click here, and then you can go run time, and then you can uh, in the instant what you can do, there is one run icon, so you can click this run button. Okay, and after this I'll be giving you one snippet, which is this one. Here is the code. So first script is for model 1. So this is the code for model 1 prediction. We have two models, like two algorithms output. So this is for model 1. So what you have to, you just have to type the cover. I'll give you this updated one. Okay, you just have to press shift enter, and then it will ask you for the image. So you can directly go to dataset and select the for image based on the dataset and model, as we have uh, up, up passing the rise one dataset. Okay, so we can pass any cloudy image of this dataset, and once you do this, so it will upload it automatically and give the prediction. Whenever you want to make the prediction with model 1, so then you have to execute this code, and whenever you want to run with model 2. Okay, so let me write the model 2 code as well. So then what you have to do, you have to run this code. I'll give you this code. Okay, you don't worry. So this is for model 2. So it takes some time for making the prediction, as we are using GAN model, right? So it takes time to generate an image, then descriptive is concept is there, right? Which will compare the images, generated images and actual images, and based on that, it create the final result, right? And if your professor asks you why it is not giving a clear picture in the real time image, so you can say, right, I given you the technical reasons, right? We have used that GAN network, right? So with the GAN network, just a second, it has not plotted the image. Okay, actually we want it should also plot the image, so let me do some modification. So now I think it will plot the images. What I was saying, so you can see we are using GAN network, right? And we have provided very limited data to GAN network. And we have just provided some, I don't know how much images are is there in dataset. You can calculate. So let me calculate it. So there are only how many images are there? Uh, 1, 5. Can't we get the like this way? Okay, database. Okay, that's why. So in datasets, we have around 3,000 files, right? Which is very less. So to train the model, we need a huge data set. So you can say key on internet we have got these two data set only, Rise 1 and Rise 2, which have limited number of images. And you can say like this is the data set which is collected from different satellites, like Rise 1 satellite, Rise 2 satellite, and with this data set, you can say like this is some area, yeah, satellite images. So what is happening when we are providing any cloudy images with this respect to this same data set, so it is giving good result. Why it is giving good result? Because we have trained the data set or our algorithm on the same data set, right? So that algorithm know key where is the place and where is the place and what exactly ground truth is that particular image. Means key whatever areas these are, so algorithm knows key what exactly in real world how exactly it looks, right? Like, right, because we have passed the cloudy images as well as ground truth, right? So that algorithm know the ground reality, ki how exactly that particular satellite view look like. Okay, so whenever we are passing cloudy images, so that time algorithm, what algorithm is doing based on their learning key how exactly that particular places look like and the cloudy images, so it is just creating their own image on generating own image, and based on that it is giving real output. But in our cases what is happening, we are providing some image which is not from our satellite image, that is collected from some wells else satellite, and that is like that is also like a different area. Due to that, algorithm is not able to give the correct prediction. It is removing the cloud as per the GAN network learning, right? So based on that, it is giving the output. It's learning and generating the output, but not 100% accurate, because you can say ki the picture quality is very low. It is just 48 by 48 pixel. It is nothing but the icon kind of image. So if you check this icon pixels, na, if you go and check this simple icon is resolution, so that is even more than 512 pixels. Okay, so your satellite image is very you can say like the satellite input images is very low quality, and that is collected from some other satellite, and it is some other area. So due to that algorithm is not processing, and we can you can say like if we get the ground truth of that particular area, so then we can retrain the model and we will get a good accuracy, like that you can say. Yeah. tell your teacher the technical answer. Okay, don't no, like answer whatever question they will ask, just answer it properly. They will understand, they are also teachers, right? So they know how exactly these things works. Okay, so this way you can run the code in Colab. Okay, so I'll be giving you this notebook notebook file, so you can take the reference and copy the code block wise, and you can paste into your own Jupyter notebook. Or else what you can do, I'll provide you this collab. Okay, and what you can do, you can just go to this file, and then you can just upload notebook, and you can upload whatever notebook I will give you, that you can upload directly. Okay, just the only thing is key, you have to upload a collab notebook, collab zip file. Okay, and then you have to execute this code block wise. First run this block, then run this block, then run this, then run this, like that. Okay, then only it will work. So instead of providing code manually, I'll just give you this notebook. Okay.
Thank you friends for watching my video. If you are new, then subscribe channel and share with your friend. Thank you.